I am the Nature Hacker, and this is your world. Today I want to talk about advanced mechanistic physics, AMP, or advanced Newtonian physics. I kind of want to leave Newtonian. Well, maybe I'll include Newtonian just so people know where we're coming from, because it follows the heritage of Newton. It's not Newton's physics. This isn't your Newton's physics. This isn't your grandpa's physics, okay? This is advanced. Like advanced talking like UFO, outer space technology, okay? This is like being able to make routine trips to the moon. Like, oh man. With advanced Newtonian physics, we can make routine trips to the moon like nothing. Like absolutely nothing. Like going to Pluto would not even be close out of the question with advanced Newtonian physics. I don't believe that this is complete. I believe there's at least one more law out there, and I don't think I'm going to be the one to find it. There's at least one more, I can tell. Because we haven't reached a universal constant yet. We haven't reached the constant yet. Once we reach the constant, then we'll be done. But as far as right now, I don't have the constant. My laws, NatureHacker's fourth and fifth laws of motion, don't have the constant. So we have to find the constant. The constant will be in the sixth or seventh law. I don't know. Maybe it's 6, because 6 is the number of man, Maybe we can only get to 6 and God has 7 or something like that. I don't know. But I know there's at least one more law out there. So keep your eye open. Now, I want to describe the 2 laws of motion that I just described. I don't want to say discovered them, because people have probably discovered them and been able to use them a little bit. But nobody's really put pen to paper, made it official, and fully defined it. Once you have something fully defined, it tells you things that even the person who defined it didn't know. That's what's so cool about it, is it gives you new information because it builds an entire framework that you can work within. Now, before we had Newtonian and non-Newtonian physics. Why was this? Why was some physics non-Newtonian? How come some physics can't be described by Newton's laws? Why is that? Well, because Newton's laws, ladies and gentlemen, aren't complete. It is possible to fully define the way motion works in the universe. To fully define it. That nothing is non-Newtonian. We could stick with the Newtonian word, but nothing is non-mechanistic. Nothing cannot be defined. Okay, so there's more of Newton's laws out there, quote unquote Newton's. There's more laws of motion out there that were yet to be discovered. That's all it means. If there's non-Newtonian stuff, that means that Newton's laws were not complete. So I've discovered 2 of these, the 4th and the 5th law. The 4th law defines force transfer. What this means is that in Newtonian physics, the first 3 laws, force can only be applied orthogonally to each body. So you have, let's say you have a ball right here, right? And you're pushing with this. The only force that's applied is that what's coming directly perpendicular to that angle body there. So that ball would only get a force in that direction, even though this thing was moving in 2 dimensions. It was moving in this dimension and in the parallel dimension, right? But you're only getting the force transfer that was orthogonal or perpendicular. Now, what NatureHacker's 4th law describes is that, yes, you get the orthogonal component, but you also get some of this parallel component that is proportional to the interaction between this body and the ball, or whatever, the two bodies, the interaction between the two bodies. So the more interaction there is, and that interaction can be friction, an interaction can be many different things, viscosity possibly, whatever, lots of different things that interaction could be. So the greater that interaction, the more of this force can be transferred. Instead of just that component, you're getting all components. You know, you're getting the full shebang. You're getting this component right here, all right, which is bigger. That's the hypotenuse. It's bigger than that component. All right, so yeah, that's what the fourth law defines. And that means that now if we have more interaction with our particles, more interaction, that means more force can be applied. We don't just get the orthogonal force, we get the full force. We get some of that hidden component, that parallel component, okay?